Hello, good morning, everyone. My name is Fatima Zora, and this is the presentation about my internship experience and what I did as a project for during this internship. And my faculty supervisor was Dr. Ashia Banpour. I worked in the company Tinker and Rasor. The CEO of this company, Mark Barley, is my company supervisor. Tinker and Rasor is a leading manufacturer of corrosion mitigation instrumentation since 1948. They have many different products such as holiday detectors, locators, CP instruments, but I was entitled to work with RFIT, which is radio frequency insulated tester. On the right, this is an image taken from their website. The model RFIT is an above ground insulator tester which uses radio frequency to evaluate the effectiveness of isolation on pipeline flanges. It has features of handheld instrument, easily locates shorted bolts, is radio frequency. The measurement doesn't get affected by DC potential differences, auto shut-off features. The price is $525, and the prime customers for this instrument are the construction, oil and gas distribution companies, and public utility companies. On the right side, you'll see the RFIT has different components shown here, and the black casing, which you can see has a handle and can be opened. So I was entitled to improve this casing. Okay, so what's exactly the purpose? How does it detect the isolation? So it detects actually the galvanic or dissimilar metal corrosion. This happens when the pipeline flanges come into contact of conductive liquid, that's water, rainwater, seawater, or it might happen because the flanges and the bolts are made of dissimilar metal. So there is dissimilar metal to metal contact, and because of this dissimilar metal, there might be sufficiently different potentials caused by that, caused by degree of dissolution. So these are all the reasons that can cause this galvanic or dissimilar metal corrosion. So here is the video. I'll fast forward it to show you how exactly this instrument is used to detect the bolt which is short. Okay. Let me fast forward it. So you can go bolt to bolt to see if this deflects. Doesn't deflect, so they are not short. So this particular bolt will show the deflection all the way to the left. So it means that this particular bolt is short. So to improve this casing design, I followed the creative engineering design process, which are all these steps, and I'll be explaining these steps in my next slides. First step is to identify the need or problem. So the problem was this, like this is a big, comparatively a big instrument, not very user-friendly. So based on customer demand, the company decided some goals that it has to be pocket carry design, sleek, ease of use, aesthetic. They decided to do it this time with company color code, and finally, it has to be designed for injection molding. The challenge for this project was I cannot change any of the components inside this RFIT. So basically, there's so limitation only which extent I can go. So I can only change the probe connector with the BNC. That's all. So I started with my research, and I tried to review the literature based on the instruments, what are their purpose, and what are the design steps for them, the features they have, the ergonomic design and aesthetics of them. This is an RFID from a different company, which is, you will notice, a lots smaller and sleek design. This is a different product, but it has a camcorder design, and this is the most popular design for handheld electronic device or electrical devices. So the three common features which is introduced in this kind of devices are the physical body structure, keypad and visual display unit. As you can see, there are many shapes and sizes and difference in those electronics that we can daily see. And there are some specific consideration for injection molding of plastic parts also, such as draft angle introducing. So I can easily take out my part from the core and cavity, and the edges should be filleted, so there are reduced stress. No undercut should be present in the design or in the mold, and support ribs to be introduced, fasteners appropriate, and ejector pin locations, and some other consideration I needed to do. So I started brainstorming, and while I was doing that, I was also learning SolidWorks 2014. I learned SolidWorks 2019 initially, but I was not very skilled. So they have the SolidWorks 2014 version, so I started practicing on that, making core and cavity. Also, they have the 3D printing machine, which is MakerBot Z18. I started printing some parts to test it out. And finally, drawing the components of RFID, which I need to place inside or outside of the casing. I came up with preliminary 3 casing ideas, which one of the pistol grip, horizontal grip, and a compact one. For the pistol grip, it was, for this kind of instrument, this was not a very common type of design. So also it was not getting very aesthetic due to the component size and shapes. We are also having problem with accommodating. With the horizontal grip, it was kind of acceptable design, but it has short grip, so it was not very ergonomic. And also the components cannot be put inside. And so I came up with the idea 3, which is compact design. And at this stage, we decided that these components will stay outside. We're not putting them inside the casing. And it was not very lucrative though. And also in this stage, we decided that instead of this connector, will connect with the BNC. With this compact design, there was a problem with the circuit board element that I cannot move around. So this design also got obsolete. So finally, I was able to create a promising solution, which looks like this, basically an extended version of the compact design. It kind of made all the features that needed to, but well, let's see the assembly, how it looks like. So when I was designing all those things, assembly, components fit into perfectly, I thought, well, this was a great design. So I go ahead and print that, the prototype. So this is the 3D printed prototype. After printing, I found some unsatisfactory features. I didn't like this extended parts that is on top and on the side, that's BNC is poking out. Button was not exactly in the middle, which I didn't like. Poorly designed fastening features, I didn't realize that those are poorly designed until I tried to assemble them. It was not a very easy assembly though. I also didn't realize that they needed ribs and support. And I forgot to introduce draft. So this was definitely not ideal for injection molding. Well, then I again improved for manufacturing. The Samsung Galaxy Note 2 was my inspiration for this final design, for which I eliminated the extended parts, which made it possible to put the buttonhole exactly in the middle. And now I introduced strong fastening features. There are mounting bosses and also lips and groove, which will help both the casing to stay together very strongly. And this time introduced draft, of course, so this case is ideal for injection molding. The ribs are introduced, and finally it was easier to assemble rather than the last one. So this is the picture of the top case, and this is the picture of the bottom case. Well, this is a video that the top case and the core and cavity. And this is the bottom case with the core and cavity. Although it doesn't have the runner's gate, still it was just a preliminary idea to see if I can make that. Well, the final design, I 3D printed that. So this blue case is the finally printed part. And it also tested for assembly. It turned out good. The volume reduction for this one, so this is almost 66% less than this black casing. Still minor adjustment with measurements are needed. This casing also can be customized to some extent to use as an enclosure for a different type of instrument that this company produces. And we still need to complete the design of core and cavity with gate position, ejector runner, etc. And since they are not immediately going into production for this, so for now we are not doing that. And next step will be the mass production. So challenges regarding my project, which I faced during this time, was using the SolidWorks 2014 older version. It didn't support many features that supported in 2019, and I could not download some online models to play with. So it was a drawback. And the mold design, it has to be done with only certain set of commands, because usually it can be done with some different ways, but it didn't work for this particular software. I also had trouble with creating parting plane, tooling speed. This all because this is a very older version, so I was not used to it. The 3D printer always gave trouble with the hardware, everything. And when I 3D printed the parts, it also dimensional inaccuracy was a problem. But we figured a way to give a high resolution printing that almost eliminated this dimensional problem. The lack of experience and guidance regarding this field, I didn't have any prior experience working in a company and doing this kind of product development before. So I forgot to consider many design aspects primarily. So this was a good experience for me. Multitasking, I had to do the multitasking, especially for the first month of the internship. I had to complete my thesis writing, defense, then parallelly working on learning from online, researching, practicing about the software, and also troubleshooting many other things related to this project. So conclusion about my whole experience of this internship is it was indeed a great learning opportunity for me, and good exposure to real industry environment, of course. And I got used to working with limited resources, because sometimes it happens, resources are limited always. And never stop learning is a good lesson for me, because if I gave up learning, I could not finish this project. So I finished this project and around 45 days, and so they offered me a full-time position, which I declined for now because I'm going for the PhD. Designing is a process, not a goal, because still I think that there much more improvement can be done, especially if we can shrink the component size, the board size. That might be possible in future. Collaboration was very important to minimize errors. I collaborated with other electrical engineers here that gave me some idea that which electrical component I can move around, which I cannot, because my concentration is not electrical engineer. So it was very time saving for me to collaborate with the other engineers. And finally, communication skills make the job easier, and also it motivates me to come into the office and do my work. So these are important. Well, that concludes my presentation for today. Thank you for watching.